Alright, in this video I'm going to show you how you can create this nice suck-in effect with Unity's shader graph. It's actually quite simple, highly adjustable, and there are so many things you can do with it. Right now I'm just having them like getting sucked into this thing because they're moving towards it. You could also use it in reverse, have some kind of like magic lamp, get some Will Smith spawning, whatever. And of course you can also adjust this shader in many ways. So for example here I have this one snail. Right, so right now it's just driven like how close it is to its target. Then the more we have this suck-in effect. And then maybe you want the eyes to get sucked in sooner, so you could increase that range. Maybe you want the eyes to actually fly a lot higher. And then you get this nice effect like this. Whoops, I'll just move the eyes. Let me move the entire snail. So the eyes are moving first, and yeah, so all of the eyes. And you get this nice, it's almost like a Baroque firework, I guess. So it's pretty nice to watch. Yeah, many things you can do with it. And so let's get started. Okay, so this is the shader. I hope it doesn't look too intimidating. It's actually quite simple when we break it down into three major parts. Right here on the bottom we have the glow, doesn't matter for now. Here we have the variation of the position. Here we have the core, that is the distance to the target. And here let's just get this out of the way real quick. So this is just for the color because I use it for sometimes things that have texture. So I plug in the texture map, right? Then I just use a bool like, do I want to use this color or do I want to use base color? So for example, the eyes, I kind of forgot to texture them, so I just use a black color and then set this bool to false, so it uses the color. So this thing, from now on, we can ignore that. The real important thing, that's the vertex position node. And basically what we're doing here is we have this target that is a position in world space. Then we take this position node, also set it to world space. And now we want to figure out how close is each vertex to that target position. That was the plan that you just saw, right? So I just set it to like 0 and then 3 or whatever. You can set it to anything you want. This is where all the vertices are going to move to. And the way this works, let me try this annotation tool. I just downloaded that, so forgive me if I draw really badly. Let's make a plant here. This is the plant. And this is the snail. Let's give it some eyes. Okay. Now what I want to figure out is, right, this is the suck-in position. Let me use a different color. This is the suck-in position. And I want to figure out for each vertex, so right, all the vertices here, points, whatever, it's not a very optimized mesh. So actually lots of vertices to stretch it. Use one more color. So what I want to do now is I want to figure out how close is this vertex to this. And then I want to say, okay, you know what? Based on how close it is, I want to actually move it towards that point. So in a most extreme case, if I say all vertices, wherever they are in world space, whatever, I want them to be here, well, then this thing disappears. But I don't want to do that instantly. I want to do this based on the distance. So first things first, we have this, go to the cursor. So I have this target position and the position node, right? We just get the distance. That is going to give us a float. Basically, if you draw a straight line between those two positions in the world space, how long is that line? This is this. Now I'm going to subtract a threshold. The reason I'm doing that is when it reaches a certain point, I want it to be completely disappearing. And you can see that, for example, if the annotations stay. Nice. If I have this frog snail here, and let's go for the body, and I set the threshold to 0. And let's move the target position over here. Z is up, sorry, Unity. No, it's not, whatever. Let's see if I move the body here, right, it gets to this suck position, and you can see, because the vertices are all at different places in the world, we need to kind of have this range, basically as long as the snail is, at least say if they are in that range, I want them to be exactly at the target position, meaning every vertex is going to be exactly at the same position, which means it's basically invisible, because if they're all at the same position, there are no faces to draw in between, and that means no pixels on the screen. So I want that range. Let me bring that back. Nice. I'm going to use that tool a lot. So let's draw this here. So I want to have a threshold, right? And so I define like this, and I say if this is somewhere here, they need to be 0. But of course, I don't want to have them getting sucked in from any position, so I also have this range, and this is the suck in range, the entire range. And of course, it's a property here, right? So I can underline things too. Awesome. So the suck range, that is this entire range. But first we subtract the threshold. Let me underline this with my new annotation tool. And now what we want to figure out, how far are we, wait, one more color, purple. How far are we between in this range, right? And I want to use a value between 0 and 1. So it would be really useful if we could say, well, here we are at 0, and of course everything here is 0. And then when we are here, it will be 0.5. If we are here, it's going to be 1. And then of course, because we are past that threshold, it's also going to be 1. Because if I have that, then back to the cursor, then we can use this really useful lerp. And then we can say, okay, I just plugged in the target position here again, because then we can lerp every vertex position between where it really is, like where it is originally, the position, but also, and then we just lerp towards the target position, right? And if we plug in 0, that means there's no effect, because we're just taking the original position. If it's 1, then it's going to be all the way at the target position, what I just mentioned, right? Then it's here and it's invisible. And then we just plug that into here. And this is just the variation. We're going to get to that in a moment. But basically what we're doing is we plug this in here. Let's see the transform. And this is important to note. So this vertex position output node is always going to assume that what you plug in is going to be an object position. So if my target were like 0, 0 at the word position, I was like, yeah, all vertices towards that position, and I just plug it in like this, it would shrink the object in itself, because it's going to take 0, 0. You mean like the pivot point of the object that this shader is on, but nope, that's not what we mean. So there's this really useful transform tool. I mean, if you've used Unity before, you probably deal with like position, local position, all of these things, and this node just translates that. It says, okay, we're getting world position, that's what we're calculating. But to plug it in correctly here, we just convert it to an object position, and it does it for us. So right now I took out the variation. We can actually see that in action. Where is my snail? The body is gone. Let's set that to 0. And when we move it, I think the body has different parameters now, but it doesn't matter. You can still see it happening. So right now, we're just moving towards that, right? In a straight line. Because this lerp that we're calculating, and we're here in between this. So the threshold, I set it to, good question. For the body there is no threshold, but you can see for the shell, I set the threshold, let's see, where's the house? It uses this shader. Threshold is 8. A distance of 8 means I want the vertex to be exactly at this target, 0, 3.9, 0. Anything between 8 and 10, that's where it's going to give us this lerp. It's going to be between this 0 and 1. Okay, and so if it's like here, and you can actually see this is where the real position is, right? And it's just getting lerped, like it stays inside. And of course, if I move it out back here, then, well, it's actually coming back. And here, this is then the entire range. Okay. So let's get back to this shader. So we're just doing this calculation, right? We subtract the threshold, then we divide that by our entire range, and we just clamp it to 0 and 1, because, you know, we might be calculating this here. I only care about this middle part. Clamp it between 0 and 1, so much easier to work with when lerping, because this is actually using extrapolation. If you plug in 2, you're going to get twice the distance. We don't want that to happen. And here I just use 1 minus, doesn't make a real difference other than it's all going to be a bit easier to work with. Because this node actually gives us a value. Let me use my awesome annotation tool again. And I'm going to overwrite this. It's going to give us, wow, that's a big line, a value between 1 and 0 when we're here. So I just want to invert that. That's why I say this 1 minus. And now we have 0 and 1. Okay, and then we want to add some variation. Okay, and now we want to have some variation, right? So it's not just getting sucked into a straight line, but we can have all these like wobbly curves, and of course it would also be really awesome if we can adjust that. And so basically all we want to do is, what I did here is, I want to add something to that position. Is that correct? Yes. Well, this is like this getting sucked into this thing like in a straight line. And of course, if we add a vector 3, then it's going to be different. Now, so basically I just have this like, let's see, I hope this is not too confusing. I'm using a vector 2 for each input of this vector 3 that I want to add, right? Here we are getting, this is the vector that I'm gonna add. And I'm using this x, y, and z, so there's always like a minimum and a maximum value. And basically the reason I'm doing that is I don't want to have it go into the ground, right? So for example, for the x, I'm going to use like -2 and 2. So give me a random value between those two. Y is, yeah, that's up. So for the y, I only use like 0 to 5. Or what you've just seen me do with the eyes, I can say, give me a value between 0 and 10, so they fly really high, and maybe there's a little bit on the x and z. And of course, the z is also negative to positive. So it's basically all about the y. And just to have that option, whatever your situation is, right, you might want to have them go up and down, but not left and right, whatever. Okay, so now we know how much we want to add, but the question is when and where do we add it? And to have all these vertices fly in this nice curve, we can actually use this output and use that. As you can see, that two times it's actually going up here into my variation, because we can use that to drive those values. The first thing we do is simply, okay, how much do I want of this range, right? So I have this x and there's the, let's say, -2 and 2, and I want to lerp between those two values that I define as the range. And what I plug in here is the value between 0 and 1. So I have this simple noise, which technically might not give you a value of 1, but it's never going to be below 0, never going to be above 1. That's good enough to lerp. I think it's like 0.7 values between those. Let me actually remove that, because this might be a bit confusing when you see UV. What the hell? There are no UVs. Why are we plugging in our value between 0 and 1? And what is this offset? When we plug a float into the UV of the noise, first thing that it does, it basically converts to a vector 2 with just the two values. If I plug in 0, it's going to make a vector of 0, 0, and that is this corner here. And if I plug in 0.5, it will make a vector of 0. An annotation tool. This would be 0, 0. If I plug in 0.5, it's just going to make a vector of 0.5, 0.5, right? If I plug in 1, then of course it's going to be this top corner. And the output is simply how bright is this value. This is why I said we're not really getting 1, because you can see it's not purely white. I don't even know if you can get it with simple noise, but you can get 0. Actually, if you plug in 0 into simple noise, it's always going to be black, because that tiny corner is always going to be black. Then of course, when you increase the scale, it's going to be different. Okay, so Alright, so we plug this in, and here it's just a bit of offset in case you don't want everything to fly differently. And also one thing to keep in mind, if you plug in a value, say, of like 3, it's going to give you something here. Like this just gets repeated, and it might be here. And the point is, what might be confusing for beginners, it's still, the output is still going to be 0 to 0.7. I said, for the sake of argument, something which is 0 and 1. It's going to give you the lightness at that pixel way asking it. I mean, you could ask, what's the value here? What's the value here? Right? It doesn't matter. Always going to get that. But the thing is, of course, if all materials use exactly the same, the 0 and 1, then this will be the same for all materials. And so I just made this offset. So I say, you know what, I want this snail to fly like a different path, and then we can change that a bit. And this is why I'm just adding an offset, so it's not always the same. Now for the frequency, I just unplugged this thing and it's a bit easier to see, right? I called it frequency because if we increase the scale, you can see here, that means those values, they're going to change quite rapidly. Once again, keep in mind, our entire effect is going to go from here to here, and this is going to be like how much we're bouncing in between those two ranges that we're defining here, right? Because we're looping in between those. And so, of course, if you have like this, here it's almost 0, here it's almost right, here it's almost 0, then it's going to be very jittery. And so the higher the scale, the more jittery it is. Right here it's just almost like getting electrified or something. And if you make it really low, maybe not this low. Oh, and by the way, this is why I said, if you plug in 0, you can see that the corner is always black. So here it would actually be like a super smooth in between those two. There isn't even like a variation, right? It just goes from 0 to 0.1. So it's very, very smooth. If you increase that, still almost smooth, but now it's already going like up and down because it gets darker and brighter. And this is why we have the frequency. And this is, of course, the value you're putting in. Now, there is another thing, and that is I don't want to have the effect start when this effect starts, and I don't want this to have any effect when the effect ends. Because say right now I'm looping and I'm just always adding something in between those two ranges, right, to get this vector 3 that we add to the position. But we don't want to add anything in the end, because then they wouldn't really hit the target. It doesn't look like they're getting sucked in. So we need a way to control this effect, and it's one more time annotation tool. It is so good. My drawing orange, not that big. Yes. Okay. So basically add 0 and 1. What we kind of want is a smooth curve like this, right? So when we're starting this effect, we are at 0. This should be 0, and then here it's 1, and then we go back to 0. Right? So when the effect ends, we also want this to be 0. And of course, it shouldn't be like this, because then that means the moment the effect starts, they're going to have like this super sharp jump. We want to like smoothly ease into this adding and smoothing out. And as you can see, a curve would be so wonderfully perfect. It's on the roadmap for Unity Shader Graph. I have no hope that it's ever going to get released. And for the time being, I'm just gonna use this gradient, which is actually pretty similar. Fortunately, this preview keeps stopping all the time. So yeah. Gradients are kind of like your next best bet to get like a smooth gradient. So somewhat confusingly, it says time. It's basically just saying evaluate this gradient from left to right. If you plug in 0, it's going to give you whatever is. Wait, I have an annotation too. It's going to give you this, right? 0.5 is this, and of course here, then it's going to give you this. What is it going to give you? Well, it's going to give you the color, RGB and alpha. We only need one value really, so I stick with the alpha because it's just a little bit easier to set. And right, so that means when the effect starts, I want the alpha of this. This is going to be my output. And then I use this to multiply this vector that we're adding. And of course, so in the end, in the end and in the beginning, we want to have a value of 0. So how much do we add? Well, nothing, because we multiply it with 0. And so then we can just use this gradient. And I'm only using the alpha, and that got lost again. This is very annoying. I have it pre-made here, so let's use this one. Okay. So on the top here, this is where you have the alpha values, right? So if I click this here, you can see alpha is 0 because I want to have 0 at the start. Then I want to increase this to 55, And here I can even control it. I want to like ease it down a little bit, like smoother, and just have to make sure in the end we need an alpha value of 0. And of course I could just, maybe now it's going to be like a super sharp jump in the beginning. Unfortunately there's only blend and fixed. Obviously here it would make like crazy jumps, so keep it to blend. It's really just a sad workaround. Let's keep our fingers crossed there will be curves anytime soon, then we can like really play around with that. And yeah, this is basically the part that then does all this like wicked twisting around and making sure that at the end, when we reach the end of our range, when we reach the threshold, all the vertices are in the position of our target. And then of course there's also some lighting effect I put on top. Interesting thing to keep in mind here is that we still use that effect here. And you might think we are once again checking the target position and the word position of our vertices, right? And we get the same result here. And unfortunately, you'd be totally wrong. The somewhat annoying issue is that this happens first, the vertices, right? They get calculated. And anything that you plug into this is going to assume the changed vertex positions. So even though this is like literally connected to the same node, it's not going to give you the same results. And it would be so freaking useful to have a drop down here that says like original vertex position. That is not I've asked in Unity forums, other people have asked that. And yeah, just have to wait forever. Anyhow, trying not to go on around here. That just means we are now dealing with the changed vertex positions. It's not really an issue. You basically just have to adjust a little bit. So the point is, if you have this variation so strong that the changed vertex positions are going to be out of the suck range again, it's not going to have any effect, because then it's going to calculate this on the changed vertex position. It's going to say, oh yeah, they're super far away. We are like at 0. And of course here, very much the same, right? I use a simple noise and just a step, and I drive this step. I just realized I didn't explain any of this, what's happening. Let me explain that. So we get a value between 0 and 1 once again, but this time we're kind of using the changed vertex positions, but those things are still the same. Like, how far are we into this range that I drew in the beginning? Unfortunately deleted. Here I just use remap. That's just like fine-tuning this a little bit, right? Because as I mentioned before, this noise is going to give us like something between 0 and like 0.7. So I just remap. We get 0.0 and 0.1 out. So I plug this in, and I want to say pretend this is only a range between 0 and 0.7. So when you plug in 1, we get 0.7. And I use this to drive the step node. Step node is quite cool. It's basically, it says anything that is above that range, make it purely white and white, so I can increase this effect. This is like the most 101, dissolve effect. I've seen that used so many times now, so we can just plug that in. That does not make any sense. We plug this one in, and now we drive this effect. So, and when the effect starts, right, and this is 0, basically there's nothing. And then of course we just multiply this with the glow color. We multiply black with this glow color. Keep in mind, black is really just 0. So it says, okay, don't add any of this glow color, only add, you can see actually here the blue dots, right? And then we plug that into the emission. So just on top of the base color. Okay, so this is it for this tutorial. I hope you learned something. I hope you're gonna make lots of awesome things, because, you can adjust this in so many ways. You can, of course, also drive it through the script. You could make like a shockwave that just goes around and sets the range, like the minimum threshold for everything that's around, and you have like the entire world getting sucked into a wave or something. And I just realized I haven't... They're making really nice forms. Let's call this procedural art. I haven't set the threshold high enough, so what I showed you in the beginning for the body. So the eyes get sucked in, the bodies, wait, is that the bodies? Yeah, it's the bodies. Okay, and of course you can make this out. You can make this like a gun that sucks things in. Thing could also be a snail gun, so it actually shoots the snails in this thing. And I think the next video I'm actually going to use this for the tongue, because this is supposed to be a frog snail that has like a tongue. And I think this effect could be adjusted so you have like this really cool frog tongue shader that I think is useful for pretty much every game out there. So thanks a lot for watching. Hope you liked it. Subscribing always helps, liking, whatever. Share this video. Any questions, just leave a comment. There's also a Discord server if you want to go more in detail. I'm going to do a lot of technical art in the near future. I want to become a Jedi in it. So yeah, there will be a lot more. Thanks for watching. Goodbye.